If w1 is this set and w1 is the subspace of R3 and w2 is also another subspace of R3, then we have to find dimension of w1 plus w2, means dimension of sum of two subspaces. To find dimension of two subspaces, we have the formula dimension of w1 plus w2 is equal to dimension of individual, means dimension of w1 plus dimension of w2 minus dimension of intersection of two subspaces, particularly w1 intersection w2. Another format of this formula, I can write w1 intersection w2 is equal to w dimension of w1 plus dimension of w2 minus dimension of sum of two subspaces w1 plus w2. These two are same formula, and only the terms we have transposed and get the another format for this one. Now we have to find dimension of w1 because we need to find dimension of sum. So dimension of w1 if we have, and dimension of w2 also dimension of intersection, then we can easily tell about dimension of sum of two subspaces. For this we have to find dimension of w1. If any element xyz, suppose xyz is coming from R3, belongs to w1, then this element or constituents of the elements will satisfy the property of w1 or subspace w1. So x minus 2y plus z equals to 0. If we have x minus 2y equals to z or minus z, I can write, if I assign values of x and y, then value of z will depends on these two values. Or I can generally say, if we assign values of two variable, then value of other one will depend on these two. Means we have two choices for which I can assign values. So dimension of this one will be 2. It means dimension of w1 is equal to 2. Similarly, dimension of w2 we will find. So let xyz belongs to w2 and its constituents will satisfy the property x equal to y equal to z, as you can see in this set or set builder notation. For this, x will be the element or the structure of the element which are in w2. As you can see, elements have the xxx type. It means if I assign the value of variable x, then we can write easily this vector. Means dimension of w2 is equal to 1 because of there is only one linearly independent choice we have. Now we have to find dimension of intersection. So dimension of intersection will be how I can find. For this, I assume let xyz belongs to intersection of w1 and w2. It means that this element will belongs to individual, means w1, and will belongs to w2 also. If this element is belonging to w1, it means that constituents of elements, constituents of vector will satisfy the property of this set. X minus 2y plus z equals to 0, and similarly it will satisfy the property of w2. So x equal to y equal to z. From these two I can write element will be xxx type, means only single linearly independent choice we have. It means I can assign only the value of x, and after assigning the value of x I can write entire vector, and this vector will help to generate all elements of w2. Means the dimension of intersection is 1, dimension of w1 intersection w2 is equal to 1. Now use the formula as we discussed in this class, as the dimension of w1 plus w2 means sum will be equal to dimension of individual, as the dimension of w1 is 2 plus dimension of w2 is 1 minus dimension of intersection, and I got this as 1. So 1 minus 1 cancel out and I left 2. Means which one option is giving value 2 as the dimension of w1 plus w2? So option B is correct choice. Consider the subspaces w1 equal to this set and w2 is equal to this set of R3, then dimension of w1 plus w2 equals. To solve this problem, we have a formula to find dimension of sum of two subspaces w1 is equal to w2. So its dimension will equal to dimension of w1 plus dimension of w2 minus dimension of intersection of w1 and w2. So to find dimension of this one, we need this one, this and this. These three things we need to find dimension of w1 plus w2. What is the meaning of dimension? The meaning of dimension, if we are taking an element from W, if we are taking any element from the set, any element from the set for which we have to find the dimension of W, for which we have to find the dimension, then at how many position, then at how many position we are independent or free, we are independent or free. Means suppose I am taking, we are talking about dimension of w1. So elements in W are x1, x2 and x3. These are constituent of an element which is coming from R3, such that x1 is equal to x2 plus 2x3. It means this triplet, or not triplet, tuple belongs to R cube such that its first constituent must satisfy this condition. So we are free at two position, x2 and x3, and x1 is independent on x2 and x3. So dimension of w1 is equal to 2. Now we have to find dimension of w2. Dimension of w2, first elements in w2 are satisfying this condition, 3x2 plus 2x3. 3x2 plus 2x3. If x1, x2 and x3 are constituent of any element which belongs to W, then it satisfies this condition. Similarly, as W1, we are free at two choices, so dimension of W2 is 2. Now we have to find dimension of intersection of W1 and W2. Intersection of W1 and W2, condition constituents satisfying x1 equal to, first x1 equal to x2 plus 2x3, x1 x2 plus 2x3, and this is condition for w2, x1 equal to 3x2 plus 2x3. If you subtract these two, then x1 cancel out and x3 is also cancel out, so x2 equal to 0. It means x1 is depending on x2 and x3, and x2 is 0, so free variable only 1. So dimension of this one is equal to 1. Now apply the formula. Dimension of w1 plus w2 equal to 2 plus 2 minus 1 is equal to 3. You can find dimension of intersection by this condition. Suppose w1 is this one and w2 is this one, then find dimension by common basis element. Number of common element in common basis. So we will find basis for w1. If x1, x2 and x3, if this element is in w1, then it can be written as x1 is linear combination of x2 plus 2 times x3. x2 is same as and x3, so it can be written as x2 and 0 plus 2x3 0 and x3. This is, if you take x2 as a common, 110 plus x3 201. So these are two linearly independent, and this is a spanning set. Any element can be written as linear combination of these two. So basis of w1 is equal to 110 comma 201. This is the basis for w1, and basis for w2 will be any element of w2 can be written as x1 is linear combination of x2 and x3, and combination is like this: 2x3 x2 and x3. If you don't know how to find the basis, then you can prepare yourself seeing this video how I'm finding basis. So it can be written as x2 outside, and it will be 301 plus x3 outside 201. So basis of w2 will be 301 and second element is 201. Now you can see here this element is common in both bases. So common basis beta is containing 201, only this element, and number of element in bases is known as dimension. So dimension of intersection is 1. Intersection means common elements. So common element in bases is this, so dimension of intersection is 1. So answer of this question is 3.